Okay, so we are going to discuss about the acid, bases, and salts on other planets too. Okay, it is the extra curricular activity from your book. Okay, so the atmosphere of Venus, it is one of the planet. How many planets do we have around the sun in our solar system?
9.
8.
Yeah, including that Pluto 9.
Yes, Pluto is like it is not following or obeying the
It's
laws
approximately
given by the Kepler. The Kepler's law.
yes, yes.
Yeah. So that Pluto planet is not obeying that it does not obey the law given by the Kepler. That's why Pluto has been removed out from the list of planet. Okay.
Okay.
Yeah. So let's discuss the sequence. So in order to remember the sequence, yes, you have to just remember my stand for Mercury. In from my I am having M, my very educated mother just serve us noodles. Okay, my from here it is sun, huh? It is sun. Then we have my very educated mother just serve us noodles. So M represents Mercury. Then we have Venus. So Venus is just before the Earth. Okay, E represents the Earth, the third planet. Then we have Mars, then Jupiter, Saturn, Uranus, and Neptune. So these are the 8 planets do we have in our solar system. Okay, so we are discussing about the atmosphere of Venus. It is the second number planet. Okay, so the atmosphere of Venus in the layer of gases surrounding the Venus. See, like we have in our Earth, in atmosphere, different gases are present. Likewise, on Venus also, different gases are present. Means the atmosphere, like on Venus, we have the atmosphere. It is composed of the primarily of carbon dioxide. Okay, is mostly composed of the carbon dioxide and is much denser than the hotter than the earth. It is more denser and hotter. So what is the reason behind that the temperature of surface of the Venus is higher than the earth? It is because of the distance between Venus and sun is less than the earth. Yes, it is the first reason. And second reason is what? On the atmosphere of Venus, we have carbon dioxide, and carbon dioxide gas have the high heat holding capacity. Okay, due to which during night time also, during the dark region also, temperature being very high on Venus. Okay, everyone, you are getting the point, no?
Yes.
Okay.
Yes, I get it.
So on the surface of the Venus, the temperature is about 740 Kelvin. 740 Kelvin, which means 467 degrees Celsius. Two, it ranges like on highest temperature is about 872 degree Fahrenheit. No, it is just conversion of the degree Celsius. And the atmospheric pressure is also very high and it is about 93 bar. Okay. Roughly, the pressure found about 900 meter, which is about the 3000 feet underwater on the earth. Okay, if suppose this is the ocean and if you are going underground on the water body like ocean, so at about 3000 feet depth, okay, you will feel pressure. That much of pressure is present on Venus, so it is very high. Okay, the Venusian atmosphere supports the opaque cloud of sulfuric acid. See, opaque cloud means very like less light is being incidenting on the surface of the Venus, and that cloud are made up of the sulfuric acid. The formula of sulfuric acid, it is H2SO4. It is
Yes.
H2SO4. Yeah, it is a sulfuric acid cloud, making optical Earth-based and orbitals observation of the surface impossible. That's why in or see it is being not like transparent. It is forming the blackish cloudy atmosphere all over the Venus. That's why to observe the surface of Venus from the Earth or from the space is very difficult. Okay, because sulfuric acid cloud forms the opaque. You know, opaque means not transparent or very least transparent. That's why information to collect from the Venus becomes very difficult. Information about the topography has been obtained exclusively by the radar imagings only. So whatever the information we have from the surface of the Venus is from with the help of radar only. Aside from the carbon dioxide, see, okay, instead of carbon dioxide, the other main components is nitrogen. Means on Venus, we have nitrogen gas along with carbon dioxide. Other chemicals compounds are present only in trace amount. Very less amount of other gases are present on Venus. Okay, everyone?
Okay.
Okay. Somebody in the waiting room? No. Okay, let's continue. So the atmosphere of Venus, we'll discuss that now. See, the cloud structure in Venus atmosphere, it is been identified on the 90, it has been like got we like with the help of some like rays which were emerging from the Venus. On that basis, with the help of those radiations and with the help of radar, it has been clear on 1979 that Venus has the atmosphere where carbon dioxide and nitrogen gas present mostly. And in its atmosphere, there is a cloud of sulfuric acid. Clouds of sulfuric acid, H2SO4, which makes the opaque cloud around the Venus. Okay, it is revealed by the ultraviolet observation from the Pioneer Venus orbit. Okay, see, we have the one of the ultraviolet observation center called Pioneer Venus on the Venus or no, wait a second. Let me check that whether do we have that ultraviolet observatory on the space or not. Yes, it is. It is revealed by the ultraviolet observation from the Pioneer Venus orbiter. Okay, the one of the orbiter like satellite kind of, which is have sensitivity to sense the ultraviolet rays coming from the Venus. It is orbiting the Venus planet, and by with the help of them, on 1979 we are able to like conclude that Venus contain atmosphere on which carbon dioxide and nitrogen is present, mostly nitrogen gas. Okay, so it
Okay, sir.
is, yeah, so that atmosphere was discovered on 1979 with the help of Pioneer, which is the Venus orbiter, and which have the ultraviolet rays sensitivity tool, which helps to like give information related to the Venus atmosphere. Okay, the general information. So first it says height 250 kilometer, which is nothing but 160 miles. Average surface pressure of the atmosphere of on the surface of the Venus is 93 bar. Yes, we already gone through that. Then mass is about 4.8 into, I think it is 10 to the power 20 kg.
Yeah. It's
Yeah,
20 to
yeah,
20.
it is 10 to the power 20 kg. Composition of maize mostly carbon dioxide, which is about 96%, and nitrogen is about 3.5%. That means we have like different component on our Earth. On Earth we have 78% of nitrogen, then 16% of, no, 21% of oxygen, and we have about 0.02% of carbon dioxide. Okay. Sulfur dioxide is, okay, percent sulfur dioxide forms about 150 particles per million. It is ppm is what? It is particle per million. And argon found about 70 particles per million. Okay. Water vapors about only 20 ppm. It is very, very less. Okay. Water molecules is also present, but have the 20 ppm only. Means 20 particles in 1 million, and 1 million means in 10 lakh particles of air. Only 20 particles are of water only. Okay. Carbon monoxide is about 17 ppm. Good. Then we have helium is 12 ppm only, and neon 7 ppm. Hydrogen chloride HCl, which is about 0.1 to 0.6 ppm. Hydrogen fluoride is 0.001 to 0.005 ppm. You know now what is ppm? It is particle per million meter. Yeah.
Sir,
Aside,
maximum of these are acids, right?
which one? Yes, hydrogen fluoride. See, it is, if it is in gaseous form, then we used to say it is hydrogen fluoride. If it is in aqueous form, then it is called as hydrofluoric acid. Okay, but here they are present in gaseous form, so we used to say hydrogen fluoride, hydrogen chloride, like this.
Okay.
Yeah. Aside from the very surface layer, the atmosphere in a state of vigorous circulations. The upper layer of troposphere exhibits of the phenomenon of super rotation. OMG, means there is a very high speed wind are being producing continuously, in which the atmosphere circles the planet in just 4 Earth days. Much faster than the planet sidereal day of 243 days only. That means, see, on the third law of Kepler, we have already understood that the distance from the sun to the planet, okay, it is nothing but the mean distance between, and it is represented by the r. It is r. What is r? It is the mean distance between planet and the sun. And the period of revolution is represented by capital T. So we know, according to the third law of Kepler, the square of period of revolution is directly proportional to the mean distance between the sun and the planet. It is cube of it. It is cube of the mean distance between planet and the sun. Is it or not? If distance is less, then period of revolution will be
greater, less only.
no, it is inversely proportional.
Yeah, inverse is.
Yeah, inversely proportional. Yes. If we will increase the distance, then period of revolution will be higher. So for Earth, we have period of revolution is about 365 days and 6 hours. Is it or not?
Yeah, sir.
Yeah. But for the Venus, it is about 243 days only, because the distance between the sun and the Venus is less than the Earth. That's why it takes a very less time as compared to the Earth to complete one revolution as well as its own axis, means the rotation. The wind supporting super rotation blow at the speed of about 100 meter per second. It is the wind speed on the surface of the Venus. It is very high.
Sir, so if we release a kite in the atmosphere of Venus, so it will return to the same place. Yeah. If we release a kite in the atmosphere of Venus, so it will rotate and come back to the same place in just 4 days.
Okay, we'll go through that also.
Yeah.
It is a fact from the Venus.
No, sir, I was
Okay.
just asking because the earlier,
Yes, yes.
uh,
If you will release the string, but
yeah.
it may go anywhere because
No, if
where.
it
Yes,
travels in the
yes,
same
yes,
direction.
yes, 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 yes. Okay. The wind supporting superrotation below the at the speed of 100 meter per second, which is nothing but a 360 kilometer per hour or 220 meter per hour or more. Winds move at the up to about 60 times the speed of the planet's rotation. Okay. So the wind speed is very high as compared to the rotation of the Venus planet, and which is about 60 times higher. While Earth's fastest wind are only 10 to 20% of the rotation of Earth speed only. Okay, but on Venus it is about 60 times higher than the speed of rotation of the planet. On the other hand, the wind speed becomes increasingly slower as the elevation from the surface decreases, with the breeze barely reaching the speed of about 10 km per hour to it is nothing but a 2.8 meter per second on the surface. Why? Because due to the resistance of other gases particle as well as particle. What is the gases? Is nothing but the particles, and particles have the gravitational force with the planet surface only. Okay, that's why their wind speed is decreasing on the surface and it is very high above because particles are very less above the surface of the Venus and low resistance and low gravity works on them. That's why they have very high speed. Okay, above the
Okay.
high sun. High. Near the pole are anticyclonic structures called polar vortices. Each vortex is double-eyed and shows the characteristic S-shaped pattern of the cloud. Above there is an intermediate layer of atmosphere which separates the troposphere from the atmosphere. Okay. Due to the high wind above the surface and very low on the surface, okay, there like cloud and whatever the material present on the atmosphere which forms the V-shaped pattern of clouds. S-shaped pattern. Okay.
Okay, sir.
And the atmosphere and troposphere, they are, you can identify them separately on the Venus. The thermosphere is also characterized by the strong circulation. See, due to the rotation speed of Venus is very high as compared to the Earth, whatever the atmospheric layer we have on the Venus is different from the Earth. Okay, but very different in its nature. The gases heated and partially ionized by the sunlight. See, what is ionosphere? It is the surface above the Venus planet where all the gases they get ionized. Okay, that particular area above the like in atmosphere of the Venus is called as ionosphere. Okay, due to the radiation, due to the ultraviolet rays, gases present in atmosphere they get ionized. Okay, that sphere is called as ionosphere. Okay.
Okay, sir.
Okay, so sunlight, the gases heated and partially ionized by the sunlight in the sunlit hemisphere migrate to the dark hemisphere where they combine to the downwell. Let me see what is downwell.
So downward means that lower part of the atmosphere.
Okay. Yes, that's why it forms a set structure like this.
Yes.
Mhm. Okay, it is due to the rotation. Okay, so this is all about. So if we will conclude that from the atmosphere of Venus to the Earth, Venus have very high percentage of carbon dioxide and then nitrogen and then other gases. Water present only 20 particles per million in atmosphere of the Venus. That means there is very less humidity is present. Okay.
Okay. Yeah.
Yeah. So if we will conclude that there is no life possible because temperature is also very high, which is about more than 400 degrees Celsius. And it is not possible because we cannot survive on summer season up to the temperature of 60 degree, 40 degree. Okay. So how can like life can survive on the Venus at the temperature above 400 degrees Celsius? So life won't be possible on Venus.